Okay, the problem statement is number of string appears in the substring in the appear as substring in the word. We have an array of strings patterns is given, a string word is given. We have to return the string in the pattern that exists as a substring in word. Okay, for an example, let's say our word is let's say A B C B A D. This is our word, and our patterns are let's say A B B A and A D B A D and C D. These are my patterns. Okay, so you have to say like which of the pattern is actually part of a substring of the word. Okay, how could we check? So we can check manually by A B. You have to check A B is part of there. B A is also part of this is a B A. B A D is nothing but this is a BAD. But CD doesn't appear. CD is not part of a this word. So these three are there. So our answer will be 3. Simple answer will be 3. Okay. So what should we? What are the cases we could write? Let's say like some generic example. How could we match word? So when you have to check word and pattern, let's say word equals to let's say A B C A B D, and my pattern equals to A B D. If it is my pattern, let's say 2 strings are there. So if this is a pattern, what is our generic approach? What we could do, brute force, using a brute force, we can point I here and point J here. And for this I, the 0th index 0, 1, 2, 3, 4, 5, 6, 7. For this I at the 0th index, so I can compare, take 3 substring, like up to this length I can do, up to this I can do, and for this 3 I can compare J. If A and A is matching, I will increment J, J. So first I have to check what 0 and 0. First is 0. This is pattern. So 0, 1, 2. If both are matching, then I should have met 1 and 1. So how could I get 1? Should I increment I? I can increment I, but another way is like I can increment J, and write is as what equals to I plus J, and this is my J. We can write this way. So right now I is 0, 0 and J is 1. So this is 1. We can 1. It is again matching. Again I should have matched. Then J will be incremented. J becomes 2. So 2 should be matched with this 2. So how could I match? I is 0 and J is 2. So 2 can 2. So I plus J I can do it. But here it is not matching. If it is not matching, we'll do what? We can reassign. We will check. We'll increment the I. And we will simply check that whether this is matching or not. If this is matching, then fine. If not matching, we'll break. If something is not matching, we'll simply break the loop and check the for I. So here 1 should be checked with the 0. So initially it is not matching, fast character is not matching. We'll break the loop. And we'll do the next one. So I will here. So in this place, so J will be again initialized as the 0. Okay, so this is also not matching. So again I will break the loop and I will initialize the third index. Now here see I is matching. Yes, I and J is matching. So I is right now 3 and J is 0. So it is matching. Third index is 0th index. Now how could I write? Now J will become 1. I will become 4. How could I match? You can see I is nothing but my 3. Earlier 3 plus 0, I plus J, I plus 1. It is a matching. Again J comes in this place. J matching. Yes, J and I are matching. I come this place. Yes, not this. I is staying in third index actually, but I plus J will check this one. If both are matching, yes, matching. If it is matching, J will be incremented by 2. And it will be 5. 5 is nothing but 3 plus 2. So I plus 2, 5. So J will here. J will this place. I will here. So it is matching. Yes, if it is matching, J becomes 3. So when the moment J will out of index, that time we'll check whether J is found or not. We can use a flag, one flag, to whether it is found or not. If it is found, then we can make not found. Any mismatch occurs, then it's a case like where it is a we can say it is not matching. Okay, so what actually I mean to say, like one flag, if whenever the mismatch occur, we can make the flag is false after the loop ends. Like when the j is ends, that time flag becomes true. That means it's a match. Otherwise, it's a mismatch. Okay. Let me rewrite the algorithm. Let's say our function means it's the number of substring SS. So what is given? What is given and patterns are given. Patterns are given. So what we need actually, first calculate the length of the word. So what I can calculate. So word dot length, I can get the length here. I can get the length here. Okay. So this is my n. So another thing, I need the answer, where I am storing my answer. So answer equals to 0. So what I can do here, I can do, so answer equals to 0. So what I can do, for each pattern I have to check for pattern, for let's say each pattern P, I am checking patterns in the patterns. So each pattern P present in the patterns array, I am checking that. So for that, what I need to do, I can initialize my I at the 0th index. I is the 0th index, and initialize my aim is nothing but I am checking the length of my pattern. Checking the length of my pattern. So aim equals to p dot length. Fine. So what I can do right now, for each aim, so for now I can, for each character present in there. So what I was doing, let me take that example again. Let me put this example here. So here, what could I do? What I could do, like where for each I am checking for each pattern. So I'm writing on a while loop, while my I less than n, but should I write only I less than n? Is it possible if I write I less than n, will it fine? So it is not fine. See, let me give you an example here. Let's say my pattern is, if I remove all the I, and let's say my pattern is A B D B. Okay, and at, at the same time, sometime, let's say here in this, sometime it will come in this place. So this place I can compare. Okay, so in this place I can compare, but think of this example, thinking example. So A is compare. Can I compare this A and this A? No, because see, the length of my pattern is M, and I should be I, whatever the current position of I, and it should contain the at least that many character. It should contain that many. I can compare C with this here in this case. So it will compare. It is fine. But whenever I come this place, I cannot compare because I need at least 4 characters to be compared. But here only 3 character presents. So whatever my current index I is present actually, whatever current index I is present actually, I should have check I and what is the length of this one. Including that, it should be equal to, less or equals to my character total number of digit present in the my word. So that's why I can write I plus m, it should less or equals to my whole word. Otherwise, let's say I is at one point, in that point I cannot calculate n, like I plus m go can be out of bound, out of index. So to overcome this out of index error, we will check I plus m should be less or equals to n. Fine. So here one is there, and another here, let's assign one value flag. Let's say flag is equals to true. I will consider everything as a true. Every case as a true I will consider. So here for each index I will do another for loop for j starting with 0, j less than m, j plus plus, j plus plus, For each character, I am checking if in this for loop, if any character get mismatch, if j, if flag, sorry not flag, if word of I plus j, word of I plus j is not equals to word of, sorry not word, pattern of j, pattern pattern of my j, if anything got mismatch, that time I will simply make this flag equals to false, because see, I am considering flag will be true, but pattern mismatch, so flag equals to false, and we break the loop, because whenever any mismatch happens, do we have to again rerun the loop? No need to check of that, so it will false. So this is how this loop ends, outer inner loop ends. Now the second while loop, it will do like at the end, if it will get, if it is get like at the end, it is get if the flag becomes, if the flag becomes that false, I will stop the loop. Otherwise, I'll increment the loop, and so if wait a minute, not this one, this one. So if my flag becomes true, like at the end, if my flag becomes true, if my flag equals to true, that means my flag never broke, like flag never becomes false. That means what? The pattern matches. Whenever the pattern matches, then flag will never fall. So that means we can do what? We can increase my answer. So answer plus equals to 1, we can do that. Answer plus equals to 1, answer plus equals to 1, and again break this loop, this inner loop I can also break, middle loop, because see if flag becomes false, then I can continue check for the next index. So even it becomes true, why need to check the next index? So I can stop this, we can simply do what, like break. Otherwise, if it is not the case, I will simply do I plus equals to 1, I plus equals to 1. So I will check for the next index, and here the middle loop ends and outer loop also ends. At the end, I will simply return the answer. Return the answer. So what will be the time complexity and space complexity? So see, first let's say let define something. Let's say n equals to length of word dot length. Okay. Let's say m equals to average length of pattern. Average length of patterns, average length of patterns, it, because patterns names are not constant, it is could be differs. So m and k, let's say it is the length of patterns, so patterns dot length, patterns dot length. So what is the time complexity? So for sure we have to check for each and every pattern, so big O of k. So here my loop can run to big O of n times. Sorry, not here. Here it run to big O of n times. So zero, I from running from 0 to I plus m less than n. So it is actually running from 0 to n minus n. This n minus is nothing but my, it could be considered as a n if my n is very larger than n. This is the case. And this is second loop also go for big O of n. The time complexity becomes big O of n into m into k. So it is too much time complexity. See, fast loop we can't avoid. For each pattern I have to check. That loop I cannot avoid. But this thing can be avoided. So how could we avoid? If you use KMT algorithm. So if I use KMT algorithm, this n cross n become n plus m. So then time complexity, if I use KMP algorithm, that time my time complexity could be big O of n plus m into k. m plus n into k. Let me rewrite it. Becomes time complexity becomes big of n plus n into k. So if my n, m and k is nearly equals to n, that time or something very smaller than n, or very n is very smaller than n, so that time it is big of n or something. So anyhow, let me write a generic approach. Generic is this is a generic big of n. Okay, space complexity. Here we are not using any extra space apart from our pointers and the flag. So we go for here space complexity. If you know the KMP, you know the system will be big of n. So the thing is, you please understand the KMP algorithm. You can watch any other my video or any other's video, doesn't matter. Please understand the KMP algorithm. It's a very basic but very useful algorithm. It can be asked in many interviews as well. So please understand the KMP algorithm, but you have to understand the intuition, otherwise you will forget. So you can watch my video, it will be in the description, or you can watch any other video. This is how we can do. Okay. So instead of doing that many stuff, you can do another stuff in a very basic way. You can also do one thing. So one thing, like use the predefined built-in functions. So that will be much easier if you use built-in function. So that time built-in function means this one. So let's say I'm using built-in function. So I no need for n. This n is not required as well. So I simply do what? I'll simply write if let's say find is the built-in function. So each and every language have their own built-in function. Please go through it. Like find in Python, substring in C, Java. I forgot actually right now. But if I say let's say word dot substring or find, let's say I am using find. Let's say find, if it is find the pattern p, if it is return something. Usually substring this built-in function return the first occurrence of the substring. If doesn't present, it return -1. So I'm writing if it is not equals to -1, that means what? We have found the substring. So I will increment answer plus and at the end that's all it is needed. But built-in function generally don't use KMP. It is a brute force approach. So KMP is the best solution for this case as well. Again, so at the end I will return the answer. That's all what you have to do. And the time complexity, it will be same to the previous. It will be n into m into k, because sometimes it is not taking that much of time. Okay then, hope you understand. As always, but before that, please one LeetCode number 28 is a basic example of like you can use KMP on this case. I have my video in LeetCode 28 program. I explained the KMP algorithm. Actually, this is totally KMP algorithm. I explained everything. So you can watch this, or you can watch any other video you like. So, but please understand the KMP. It is a very useful, but very hard and as well as very easy algorithm. Okay then, thank you. As always, if you find any mistake in this video, please let me know. And if you find any useful information in this topic, please also let me know. Thank you. Bye bye.